Okay, so this video is going to go over pages 9 through 11 in your packet. So we're going to go over impulse and momentum together. So a couple things is we got some equations to look at. We have impulse, J equals F times T. Okay, so remember J is going to be your impulse. Okay, then you have your momentum, P equals M times V. Or you can have P equals M times change in V, which would just be VF minus VI. Okay, so those are your main two. So impulse is a change in momentum. Okay, if you change the force acting on an object or change the time acting on an object, what you're going to do is you're going to make that object start to change its velocity, which therefore changes its momentum. So that's why we can set these two right here equal to each other. Okay, so we can say that M times V equals F times T. Okay, so that's called impulse momentum theorem. Okay, so we're going to go through and try to practice some of these. So number one, a force of 10 newtons towards the north acts on a body for 5 seconds. So I have a force here. We're just going to keep an eye on direction. Okay, the only time I really do care about direction is when there's conflicting directions, because that'll tell you when to change your sign. Okay, so just watch out for that. Acts on a body for 5 seconds. There's your time. So impulse, so that means you're looking for J. Well, this is going to start off pretty easy. Okay, so impulse equals force times time. So J equals 10 times 5. And you're going to get a value of 50. And your units are force is newtons, time is seconds, so newtons times seconds. Now B, what is the momentum change? So remember, impulse and momentum change are the exact same thing. Okay, so impulse is just a change in momentum. Okay, so if you know one, you know the other. Okay, so therefore P equals 50. And then momentum is technically kilograms times meters per second, mass times velocity. So make sure you're paying attention to this. If you know one, you know the other. Okay, so you got to be able to take those two back and forth. Now, if the body was originally at rest, so there goes your VI is at 0, has a mass of 2 kilograms, there's your mass. What is the final velocity? You're looking for VF. So I know P equals mass times VF minus VI. Okay, so P we already know is 50, equals mass, which is 2. VF, we don't know. VI is 0, so you can just go ahead and take that off. So 50 equals 2 VF. So VF is going to equal 25 meters per second. There's your answer for that one. A golf ball with a mass of 10 grams cannot have that. Okay, cannot have the grams. Remember, there's 1,000 grams in a kilo. Okay, so 10 divided by 1,000 is going to give you 0.01 kilograms. So there's your mass. After the impact, the ball moves off with a velocity of 5 meters per second. That means the ball was originally sitting there, and then it left with a velocity of 50 meters per second. So my final velocity is 50. If the ball, and it says east, but if we don't have anything that says west, don't really worry about that. If the ball and the club were in contact for 5.0 times 10 to the negative 3 seconds, okay, this negative 3 is also saying you can move this decimal to the left 3 times. 1, 2, 3. So that's the same thing as saying 0.005 seconds. But that is not an equation, that's just a value. So when you do that, if you're going to keep it in scientific notation, make sure you put parentheses in the calculator. So I would put this whole thing in parentheses before you put it in. Now, what is the average force acting on it? So we have time. Okay, we're looking for force. So I got a lot of stuff going on here. Okay, so when you see a lot of stuff, things like mass, velocities, time, force, that means you're dealing with impulse momentum theorem, which is the F times T equals M times change in V. Okay, so my force, I don't know. Okay, when it says average force, we just mean force. You don't have to find, there's no special way to do average. So force times time, okay, so time would be 0.005 equals my mass, which is 0.01. Okay, VF minus VI, so 50 minus 0, which is 50. Okay, just be careful. I'm seeing mistakes on either one, typing in the time wrong in the calculator, or messing up the conversion from grams to kilograms. So you should get a value of 100 newtons. Number 3, a 2 kilogram ball moving initial velocity of 3 meters per second. So there's your mass. Moving the initial velocity of 3 meters per second to the right. Okay, so there's your VI. Okay, and we're going to pay attention to that right. Is acted upon by a constant force to the left. Okay, so we got conflicting directions now for a period of 3 seconds. There's your time. After the interaction, the ball is moving to the left with a speed of 6 meters per second. There is your VF. So it does not matter which one you pick. The sign will just be different. Okay, but you need to be careful with this is if I have one going to the right and one to the left, they cannot both be positive. So I'm going to say the one coming in is positive to the right, and the one bouncing back or going back is negative. So VF is going to be negative 6 meters per second. Determine the force. So we're going to use impulse momentum theorem again. So F we don't know. T is going to be 3 seconds equals mass, which is 2. VF minus VI, so VF is negative 6 minus 3. Okay, and you should get a value of negative 6 newtons. Okay, so again, just watch out for your signs there. Okay, just make one of them negative, it doesn't matter which one. So if you got 6 newtons because you made the first one negative, that's fine. Okay, so it's going to give you the same value. 4, you push an object with a force of 3 newtons east for 5 seconds. So I have force, I have time. What's the impulse? So we're going to just do J equals F times T. So J equals 3 times 5, and you get 15 newtons times seconds. 5, what impulse gives an 8 kilogram mass a change in velocity of 4 meters per second north? Okay, so I'm seeing with this is we have a mass and we have velocity, and people are like, well, J is impulse. Well, J equals F times T. So how do I solve for this? Remember, J also equals P. So I can find it just by doing the momentum equation. Okay, so impulse, so I can do mass times change in velocity, or mass 8 times velocity, which is 4. And you get a value of 32, you can say newtons times seconds. You can say 32 kilograms times meters per second. Either one's fine as long as you have one of those. Okay, so either one of those would be your answer. Number 6, suppose you throw a ball against the wall and catch it on the rebound. How many impulses were applied to the ball? Okay, so first impulse is me throwing the ball. There's one. Okay, second impulse is the ball hitting the wall and bouncing back. Oops, don't know what had happened there. It hits the wall, bounces back. So there's impulse number 2. Okay, impulse number 3 is when I actually catch it, so it's going to stop it. So there's impulse 3. So there's 3 impulses there. And so 1 is when you throw it, when you start the movement. 2 is when it hits the wall and bounces back, you change its momentum. And then 3 is when you catch it. You're stopping it, therefore changing its momentum. Now impulse, which one was the greatest? Okay, so you got 3 options there: when you throw it, when you catch it, or when it hits the wall. So I would say when you actually have an object moving with a positive velocity and it hits something else and actually changes its direction to negative, that's going to be a little bit more of an impulse than just getting something going. Okay, so I'm going to say when it hits the wall, that's the greatest impulse. Number 7, a 3 kilogram object has been accelerated by a constant force of 12 newtons. So we have mass, I have force from 10 meters per second south, okay, to 18 meters per second south. So that's VI, VF. How long was the force acting? So that means you're looking for T. So we're going to plug in. So 12, force times time. So 12 times T equals mass, which is 3, times VF minus VI, so 18 minus 10. Okay, and you should get T equals 2 seconds. Now, what impulse was given to the object? So remember, J equals F times T. Okay, so you have force now is 12. Time would be 2 seconds now. So that would be 24 newtons times seconds. 8, a constant force is applied to a 2 kilogram object. Okay, so if a mass initially at rest, there's VI is 0, moved 4 meters west in 2 seconds. That's actually distance and time. Okay, what is the impulse applied to the object? Okay, so J equals F times T. Well, I don't have force, I'm not going to find that anywhere. So impulse also equals momentum. P equals M times VF minus VI. Okay, so we're looking for P. We don't know what that is. So P equals my mass, which is 2, times VF minus VI. Well, VI is 0. Now, you can find your final velocity. Remember, V equals D over T. So V equals D over T. So 4 divided by 2, and that gives you a final velocity of 2. So multiply those, and you get a momentum or impulse of 4 kilograms times meters per second, or 4 newtons times seconds. Last page, a railroad freight car with a mass of 5 times 10 to the 4th kilograms. There's your mass. Is rolling along a level track at 0.30 meters per second east. So there's VI, and we're going to pay attention to direction. A rope trails behind it. If you pull on the rope with a force of 250 newtons, so you're actually trying to stop it, so that means this is technically a negative 250 newtons. And that's your force. In order to stop the car, so therefore VF is going to be 0. How long would it take to bring the car to rest? So it means you're looking for time. Okay, so we're going to do our impulse momentum theorem. So F times T, so negative 250 times T equals mass 5 times 10 to the 4th times VF minus VI, so 0 minus 0.30. Okay, so just be careful that's always final minus initial. So multiply the sides on the right, divide it by negative 250, and that's going to give you a time of 60 seconds. Now, ultimately, if you did not say that it was negative 250, it's not going to really affect your answer. It's just going to say you got negative 60 seconds, which you can't have negative time. So as long as you know to fix that, you'll be fine. 10 meters from the point you start pulling, another car is standing. Will there be a crash? That means we don't know how far this train's actually going to go, so that means you're looking for distance. Now, this one, we're not going to try to throw this one at you during a quiz or test necessarily. We're just showing you how Daffy T can be brought back into the mix. Okay, so we're looking for distance. VF is going to be 0, VI is going to be 0.3, and time is 60 seconds. So that means we did not care about acceleration, so you'd use equation number 2. So D equals VI plus VF over 2 times T. Okay, so plug in. So VI is 0 plus 0.3 divided by 2 times your 60. And that means it's going to go 9 meters. So if the other car is in 10 meters, that means no, it's not going to hit. It's not going to hit it. It's going to stop short. Number 10 was the average force. So you're looking for force to stop a hammer. So that means V final is going to be 0. Okay. With a change in momentum of 25 newtons per second. Okay. So there is your P or J in 0.05 seconds. So I was given time. So honestly, I didn't even need VF equals 0. I just get in the habit of seeing that. So I am just looking for force, and I know J equals F times T. So J is going to be 25 equals force, I don't know, and time is 0.05. So divide both sides, you get a force of 500 newtons. There's your answer for that one. 11, an object with a mass of 10 kilograms. There's your mass. Moves along a straight line with a velocity of 10 meters per second west. So that's our VI. We're going to pay attention to that west. A constant force then acts on the object for 4 seconds. There's your time, giving it a velocity of 2 meters per second east. So V final is going to be negative 2 meters per second since it's going east. Okay, calculate the impulse acting on the object. Okay, so we're looking for J. Okay, do I have force and time? Nope. Okay, so J equals P. Okay, P equals mass times VF minus VI. Okay, so my mass is going to be 10. VF is negative 2 minus your initial, which is 10. Okay, and you multiply that out, and you get negative 120 newtons times seconds. Or kilograms times meters per second. Either way works. Okay, so again, as long as you make one of the velocities negative, it does not matter. It's how you look at the direction. Now it says determine the force. So that means you're looking for F. Well, now we know J. So J equals F times T. So negative 120 equals force. And then time is 4 seconds. So divide both sides by 4. And you get a force of negative 30 newtons. And that'll end that one.